These ML concepts confuse even experienced data scientists. What is overfitting in machine learning and how can it be avoided? Answer: overfitting is a common problem in machine learning where a model becomes too specialized to the training data and fails to generalize well to new, unseen data. This happens when the model learns patterns and noises present in the training data, resulting in high performance on the training data but poor performance on new data. To avoid overfitting, we can use techniques such as early stopping, where the model's training is stopped when the validation performance stops improving, and regularization methods like loan or L2 regularization, which penalize the model's weights to prevent overfitting. These methods help the model to generalize better and perform well on new data. Why can't we use linear regression for a classification task? Answer: we can't use linear regression for a classification task because its output is continuous and unbounded, whereas classification requires discrete and bounded output values. This means that the error function graph will not be convex, increasing the likelihood of the model getting stuck at local minima rather than the global minimum. As a result, linear regression is not suitable for classification tasks. Why do we perform normalization in machine learning? Answer: we perform normalization to bring all the features to a certain scale or range of values, which helps achieve stable and fast training of the model. Without normalization, there is a risk that the gradient will not converge to the global or local minima and may oscillate back and forth, making the training process unstable. Normalization ensures that all features are on the same scale, allowing the model to learn more effectively and efficiently. What is the difference between precision and recall, and how do they measure the performance of a model? Answer: precision measures how many of the predicted positive examples are actually true positives, avoiding false positives and making accurate positive predictions. On the other hand, recall measures how many of the actual positive examples are correctly identified by the model, avoiding false negatives and identifying all positive examples correctly. In other words, precision focuses on a model's ability to accurately predict positive examples, while recall focuses on the model's ability to identify all positive examples. Both metrics are important in evaluating a model's performance, as a high precision does not necessarily mean a high recall, and vice versa. What is the difference between upsampling and downsampling in machine learning, and what are the advantages and disadvantages of each method? Answer: upsampling and downsampling are two techniques used to address class imbalance in machine learning, where one class has a significantly larger number of samples than the other. Upsampling involves increasing the number of samples in a minority class by randomly selecting and duplicating them, while downsampling involves decreasing the number of samples in the majority class by randomly selecting and removing them. The main advantage of upsampling is that it does not result in data loss, but it can lead to overfitting and high training accuracy, but low validation accuracy. On the other hand, downsampling can result in data loss and loss of critical information, but it can help to reduce overfitting. Ultimately, the choice between upsampling and downsampling depends on the specific problem and dataset being worked with. What is data leakage and how can we identify it? Answer: data leakage occurs when there is a high correlation between the target variable and the input features. This can be identified by observing a model's performance on both training and validation data. If the model performs well on both, but poorly in actual predictions, it may be suffering from data leakage. This is because the model has learned to rely on the highly correlated feature rather than learning to make accurate predictions. As a result, the model's performance drops when it is used to make actual predictions. Data leakage can be identified by monitoring the model's performance on both training and validation data and looking for signs of overfitting or poor performance in actual predictions. What are the key metrics included in a classification report and what do they measure? Answer: a classification report provides key metrics to evaluate a model's performance, including precision, recall, phone score, support, accuracy, macro average, and weighted average. Precision measures the accuracy of positive predictions, recall indicates how well the model finds positive instances, phone score balances precision and recall, support shows the number of true instances for each class, Accuracy measures overall correct predictions, macro average treats classes equally, and weighted average gives more importance to frequent classes. These metrics help evaluate the model's performance and identify areas for improvement. What are some of the hyperparameters of the random forest regressor which help to avoid overfitting? Answer. The hyperparameters that help to avoid overfitting in a random forest regressor are max depth, an estimator, min sample split, and max leaf nodes. Max depth limits the depth of the tree, an estimator controls the number of decision trees, min sample split restricts the splitting of nodes, and max leaf nodes controls the number of leaf nodes, all of which help to prevent overfitting by reducing the complexity of the model. This ensures that the model does not become too specialized to the training data and can generalize better to new data. What is the bias-variance trade-off? Answer. The bias-variance trade-off is the balance between the two types of errors that a model can make, bias and variance. Bias refers to the difference between the actual values and the predicted values by the model, while variance refers to the change in accuracy of the model's prediction on which the model has not been trained. The goal is to find a balance between these two situations where the model has learned the pattern in the data low bias but is not overfitting low variance. If the bias is too low but the variance is too high, it's known as overfitting, and if the variance is too low but the bias is too high, it's known as underfitting. The bias-variance trade-off is crucial in machine learning to avoid these two extremes and achieve a good model performance. Is it always necessary to use an 80-20 ratio for the train-test split? Answer. No, it is not always necessary to use an 80-20 ratio for the train-test split. The main purpose of splitting the data is to have some data that the model has not seen previously so that we can evaluate the model's performance. The number of rows used for the test split can vary depending on the size of the data set, and a smaller proportion of the data can be sufficient for evaluation, such as 1,000 or 2,000 rows out of 50,000. What is principal component analysis? Answer. Principal component analysis (PCA) is a machine learning technique used to reduce the number of features in a dataset while preserving as much information as possible. It does this by identifying the most important patterns in the data and transforming the data into a new set of coordinates, called principal components, that capture most of the variance in the original data. This allows for significant reduction in data size, making it easier to visualize and analyze high-dimensional data. PCA is often used in applications such as image compression, data visualization, and feature extraction. What is one-shot learning? Answer. One-shot learning is a machine learning concept where a model is trained to recognize patterns in a dataset using only a single example, rather than requiring a large dataset. This approach is useful when large datasets are not available, and it is applied to identify similarities and differences between two images. In other words, the model learns to recognize a new pattern or object by looking at just one example of that pattern or object. This can be particularly useful in situations where data is scarce or difficult to collect. What is the main difference between Manhattan distance and Euclidean distance in calculating the distance between 2 points? Answer. The main difference between Manhattan distance and Euclidean distance is the way they calculate the distance between 2 points. Manhattan distance adds up the absolute differences between the coordinates of the 2 points along each dimension, whereas Euclidean distance calculates the square root of the sum of squared differences between the coordinates. This difference affects the way the distances are measured, with Manhattan distance being more sensitive to axis orientation and Euclidean distance being more sensitive to the overall magnitude of the distance. What is the main difference between one-hot encoding and ordinal encoding, and how do they represent categorical data? Answer. The main difference between one-hot encoding and ordinal encoding is how they convert categorical features to numeric ones. One-hot encoding creates separate columns for each category and assigns 0 or 1 values based on the category, resulting in a binary matrix representation. On the other hand, ordinal encoding replaces categories with numbers from 0 to n-1 based on their order or rank. This means one-hot encoding is used when there is no order or ranking between categories, while ordinal encoding represents categories as ordinal values. How can you conclude about the model's performance using the confusion matrix? Answer: by analyzing the confusion matrix, you can conclude about the model's performance by calculating various evaluation metrics such as accuracy, precision, recall, and phone score. These metrics help you understand how well the model is performing in terms of correctly classifying true positives TP, true negatives TN, false positives FP, and false negatives FN. By examining the values along the diagonals of the matrix, you can determine the model's ability to correctly classify instances and make predictions. This information can be used to improve the model's performance by identifying areas for improvement and adjusting the model's parameters accordingly. What is the main idea behind the support vector machine SVM algorithm, and how does it achieve separability in data? Answer: the main idea behind SVM is to map a low-dimensional, non-separable dataset to a higher-dimensional space where it becomes separable. This is achieved by finding a hyperplane that maximizes the margin between different classes. SVM uses various types of kernels to perform this mapping, allowing it to learn nonlinear boundaries and achieve high accuracy in classification tasks. By maximizing the margin, SVM aims to create a robust and generalizable model that can effectively separate data points into different categories. What is the main difference between the k-means and k-means++ algorithms in terms of initializing centroids? Answer: the main difference is that k-means randomly initializes centroids, whereas k-means++ initializes the first centroid randomly and subsequent centroids based on their distance from the initial centroids, ensuring they are evenly spread apart and reducing the likelihood of converging to suboptimal clusters. This helps k-means++ reach the global minimum instead of getting stuck at local minima. What are some commonly used measures of similarity in machine learning? Answer: in machine learning, some commonly used measures of similarity are cosine similarity, Euclidean distance, and Manhattan distance. Cosine similarity calculates the cosine of the angle between two vectors in an n-dimensional space, resulting in a value between -1 and 1, where 1 indicates high similarity and -1 indicates complete dissimilarity. Euclidean distance and Manhattan distance measure the distance between 2 points in an n-dimensional plane, with the difference being in the calculation method. Jakob similarity, also known as EOU intersection over union, is widely used in object detection to evaluate the overlap between predicted and ground truth bounding boxes. These measures are used to compare and evaluate the similarity between data points, features, or patterns in machine learning applications. Which machine learning algorithm is more robust to outliers, decision tree or random forest? Answer: random forest is more robust to outliers because it is an ensemble of multiple decision trees, and the output is an aggregate of these trees. This averaging process reduces the chances of overfitting, making random forest models more resistant to the effects of outliers. In contrast, decision trees are more susceptible to overfitting and can be heavily influenced by outliers. Therefore, random forest is a better choice when dealing with datasets that contain outliers. What is the difference between Lowen and L4 regularization? What is their significance? Answer: Lowen regularization, also known as lasso regularization, adds the sum of the absolute values of the model's weights to the loss function, encouraging sparsity by pushing less important weights to exactly 0. This automatically performs feature selection, removing irrelevant features and improving interpretability and reducing overfitting. On the other hand, L2 regularization, also known as ridge regularization, adds the square of the weights to the loss function, shrinking weights towards 0 to prevent overfitting, especially in noisy data with many features. The significance of Lowen regularization lies in its ability to automatically perform feature selection, while L2 regularization is effective in preventing overfitting. Both regularization methods help improve model performance by reducing the complexity of the model. What is a radial basis function, and how is it used in machine learning? Answer: a radial basis function (RBF) is a type of real-valued function used in machine learning that depends only on the input and a fixed point called the center. The RBF function is used in various machine learning applications, including function approximation, unsupervised learning, and classification tasks. In these applications, the RBF function is used to map input data to a high-dimensional space, allowing for more complex decision boundaries to be learned. The RBF function is also used as a kernel in support vector machines SVM to separate classes in different regions of the feature space with the maximum margin. Overall, RBF are a powerful tool in machine learning, enabling the development of more accurate and robust models. What is the SMOD method and how does it handle data imbalance in a dataset? Answer: SMOD synthetic minority oversampling technique is a method used to handle data imbalance in a dataset. It does this by synthesizing new data points using the existing ones from the minority classes through linear interpolation. This means that the model is trained on a combination of the original minority class data and the newly created synthetic data. This approach helps to avoid overfitting and improves the model's performance on the minority class. However, it also adds noise to the dataset, which can have a negative impact on the model's overall performance. Is the accuracy score always a good metric to measure the performance of a classification model? Answer: no, the accuracy score is not always a good metric to measure the performance of a classification model. This is because accuracy score can be misleading when the dataset is imbalanced, meaning one class has a significantly larger number of samples than the other. In such cases, using precision, recall, or phone score can provide a more accurate representation of the model's performance. The phone score, in particular, is a harmonic mean of precision and recall, making it a useful metric for evaluating model performance in imbalanced datasets. What is KNN imputer and how does it work in imputing missing values in a dataset? Answer: KNN imputer is a method for imputing missing values in a dataset. It works by identifying the k-nearest neighbors to a data point with a missing value based on a distance metric such as Euclidean distance. The missing value is then imputed using a statistical measure, such as the mean or median of the values from these neighbors. The k-parameter defines how many neighbors to consider, and the distance metric controls how similarity is measured between data points. This approach is more effective than traditional methods like using mean, median, or mode, as it takes into account the local patterns and relationships in the data. What is the working procedure of the XGBoost model? Answer: the XGBoost model is an ensemble technique that optimizes weights in a sequential manner using decision trees. The process starts with an initial set of weights, and each subsequent pass refines these weights by training a new decision tree. The tree tries to optimize the weights, and the process is repeated until the best weights are obtained for the problem. Techniques like regularized gradient and mini-batch gradient descent are used to implement this algorithm, making it fast and optimized. The final output is a set of optimized weights that can be used for prediction or classification. What is the purpose of splitting a given data set into training and validation data? Answer: the main purpose of splitting a given data set into training and validation data is to keep some data left over on which the model has not been trained, so that we can evaluate the performance of our machine learning model after training. This helps us to avoid overfitting and choose the best model by comparing its performance on the validation data with its performance on the training data. Additionally, we can use the validation dataset to compare the performance of different machine learning models and choose the one that performs best. This ensures that our model generalizes well to new, unseen data. What are some common methods used to handle missing values in a dataset? Answer: there are several methods to handle missing values in a dataset. One approach is to remove the rows with null values, but this can lead to the loss of important information. Another method is to remove the column with null values if it has little valuable information. However, this can also result in the loss of important information. A more effective approach is to impute the null values using descriptive statistical measures like mean, mode, and median. Additionally, more sophisticated methods like KNN imputer can be used to impute the null values. These methods can help to maintain the integrity of the dataset and ensure that the analysis is accurate and reliable. What is the main difference between k-means clustering and the k-nearest neighbors KNN algorithm in machine learning? Answer: the main difference between k-means clustering and the k-nearest neighbors KNN algorithm is their purpose and application. K-means clustering is an unsupervised machine learning algorithm used for clustering purposes, where it groups similar data points into clusters. On the other hand, KNN is a supervised machine learning algorithm used for classification tasks where it predicts the class label of a new data point based on the majority vote of its k nearest neighbors. In summary, k-means is used for unsupervised clustering, while KNN is used for supervised classification. What is linear discriminant analysis? Answer: linear discriminant analysis (LDA) is a supervised machine learning technique used for dimensionality reduction and classification. It aims to find the optimal hyperplane that maximizes the distance between the means of different classes while minimizing the variation within each class. This technique is commonly used in classification problems where the goal is to separate classes based on their characteristics. By applying LDA, we can reduce the dimensionality of the data while preserving the most relevant information for classification, making it a powerful tool in data analysis and machine learning. How can we visualize high-dimensional data in 2D? Answer: to visualize high-dimensional data in 2D, we can use algorithms such as TSNE, PCA, or LDA. These algorithms reduce the dimensionality of the data, allowing us to plot it in 2D for better analysis. The TSNE algorithm is particularly effective as it preserves local similarities in the data, whereas PCA tries to preserve the variance of the dataset. By using these algorithms, we can gain insights into the structure and relationships within high-dimensional data. What is the reason behind the curse of dimensionality? Answer: as the dimensionality of the input data increases, it becomes difficult for a model to identify patterns and optimize its weights due to the limited number of datasets available, leading to poor generalization and learning. This makes it necessary to have a large amount of data to learn the patterns present in high-dimensional data, which can be a significant challenge. Which metric is more robust to outliers, MSE or RMSE? Answer: MAE is more robust to outliers. This is because MAE takes the absolute value of the errors, which makes it less sensitive to large errors outliers compared to MSE and RMSE, which square the error values, making them more sensitive to outliers. As a result, MAE is less likely to be distorted by outliers and provides a more accurate representation of the model's performance. Why is it a good idea to remove highly correlated features in a dataset? Answer: when two features are highly correlated, they may provide similar information to the model, which can cause overfitting. Removing these features reduces the dimensionality of the feature space, making the model training faster and less prone to errors. It also helps achieve data compression without losing much information. This is a good practice because it simplifies the model, reduces the risk of overfitting, and improves the overall performance of the model. What is the main difference between content-based and collaborative filtering algorithms in recommendation systems? Answer: the main difference between content-based and collaborative filtering algorithms is that content-based algorithms recommend products based on similarities in content and services, whereas collaborative filtering algorithms recommend products based on the preferences of similar users. In content-based systems, the recommendation is made by analyzing the characteristics of the items, whereas in collaborative filtering systems, the recommendation is made by analyzing the behavior of similar users. This difference in approach leads to different strengths and weaknesses in terms of accuracy and scalability. Content-based systems are often better at recommending items with similar characteristics, while collaborative filtering systems are often better at recommending items that are popular among similar users. How would you assess the goodness of fit for a linear regression model? Which metrics would you consider most important and why? Answer: to assess the goodness of fit of a linear regression model, we would consider 4 key metrics: R-squared, adjusted R-squared, root mean squared error RMSE, and F statistics. R-squared measures the proportion of variance in the dependent variable that can be explained by the independent variables, providing a measure of how well our model fits the data. Adjusted R-squared is important when comparing models with different numbers of predictors, as it adjusts for the complexity of the model and helps prevent overfitting. RMSE measures the average distance between observed and predicted values, giving us an idea of the model's predictive accuracy. F-statistics tests the overall significance of the model, indicating whether the independent variables are jointly significant in explaining the dependent variable. By considering these metrics, we can get a comprehensive understanding of how well our linear regression model fits the data. What is the null hypothesis in linear regression problem? Answer: the null hypothesis in linear regression states that there is no relationship between the independent variables and the dependent variable. It is formally represented as H0 bedon equals 0, where bedon is the coefficient of the independent variable. This means that the predictor variable does not contribute to predicting the outcome, and any changes in the independent variable are not associated with changes in the dependent variable. Can support vector machines SVM be used for both classification and regression tasks? Answer: yes, SVM can be used for both classification and regression tasks. For classification, SVM work by finding a hyperplane that separates different classes in the data with the largest gap possible. For regression, SVM are adapted into a version called support vector regression SVR, which tries to fit as many data points as possible within a certain range of the predicted line, allowing some errors but penalizing those that are too large. This makes it useful for predicting values in situations where the data shows complex patterns. What is the concept of weighting in KNN, and how do different methods of assigning weights affect the model's predictions? Answer: in KNN nearest neighbors, weighting refers to the process of assigning different levels of importance to the neighbors based on their distance from the query point. This affects how each neighbor influences the model's predictions. There are three main ways to assign weights: uniform weighting, distance weighting, and user-defined weights. Uniform weighting gives all neighbors equal weight, while distance weighting assigns weights inversely proportional to the distance, giving closer neighbors more influence. User-defined weights are assigned based on domain knowledge or specific data characteristics. The choice of weighting method can significantly impact the model's performance, with distance weighting often improving accuracy and user-defined weights optimizing performance when specific insights about the dataset are applied. However, uniform weighting may not perform well with noisy data or varied distances. What are the assumptions behind the k-means algorithm, and how do these assumptions impact the results of the algorithm? Answer: the k-means algorithm assumes that the data is spherical, meaning that the data points are evenly distributed around the mean of each cluster. It also assumes that the clusters are well separated, meaning that there are no overlapping clusters. Additionally, k-means assumes that the data is isotropic, meaning that the data points are equally distributed in all directions. These assumptions can affect the results of the algorithm in several ways. For example, if the data is not spherical, the algorithm may not be able to accurately identify the clusters. If the clusters are not well separated, the algorithm may group data points from different clusters together. If the data is not isotropic, the algorithm may not be able to capture the underlying structure of the data. Overall, the assumptions of k-means can significantly impact the accuracy and reliability of the results. What is the limitation of the cluster shape assumption in clustering algorithms? Answer: the cluster shape assumption in clustering algorithms assumes that clusters are spherical and of similar size. This means that it may not handle non-spherical groups well, which can lead to inaccurate clustering results. In other words, if the clusters are not spherical or have varying sizes, the algorithm may not be able to identify the correct clusters, resulting in poor clustering performance. What is the scale of features assumption in distance calculations, and how can different ranges affect the results? Answer: the scale of features assumption is a concept in distance calculations that assumes features are on similar scales. This means that the ranges of the features are comparable and the distance calculation is not affected by vastly different scales. However, if the features have different ranges, it can distort the distance calculation, leading to inaccurate results. For example, if one feature has a range of 0-100 and another has a range of 0-1000, the distance calculation may be biased towards the feature with the larger range, even if the actual difference between the two features is small. To avoid this issue, data processing techniques such as normalization or standardization can be used to scale the features to a common range. What is the assumption of clusters being balanced in cluster analysis, and how could it potentially bias results? Answer: the assumption of clusters being balanced in cluster analysis is that each cluster should have a roughly equal number of observations. However, this assumption can be problematic because it can bias results against smaller clusters. This is because smaller clusters may have fewer observations, which can lead to less accurate and less reliable results. As a result, the analysis may not accurately capture the characteristics of smaller clusters, potentially leading to incorrect conclusions. What is the assumption of similar density in k-means clustering, and how does it affect the algorithm's performance? Answer: the assumption of similar density in k-means clustering means that all clusters have the same density, or number of data points within them. If this assumption is not met, and clusters have varying densities, the algorithm's effectiveness is impacted. This can lead to poor performance, making it challenging to process and select clustering techniques that align with the data characteristics. In other words, k-means clustering assumes that all clusters are equally populated, which is not always the case in real-world data. This limitation can result in inaccurate clustering results and decreased model performance. What is convergence in k-means, and what conditions must be met for k-means to converge? Answer: convergence in k-means occurs when the cluster centroids stabilize and the assignment of data points to clusters no longer changes. This happens when the algorithm has minimized the sum of squared distances between points and their corresponding centroids. For k-means to converge, the data must be spherical and well separated, meaning that the clusters should be roughly spherical in shape and not overlap with each other. Additionally, the initial placement of the centroids should be reasonable, and the number of clusters k should be chosen correctly. If these conditions are met, the k-means algorithm will eventually converge to a stable solution. How does the initial placement of centroids affect the convergence of a clustering algorithm, and what techniques can be used to ensure a better start? Answer: the initial placement of centroids can significantly impact the convergence of a clustering algorithm. A poor initial placement can lead to suboptimal clustering results, while a good initial placement can help the algorithm converge to a better solution. Techniques like k-means++ can be used to ensure a better start by initializing the centroids in a way that is more likely to lead to a good clustering result. This is because k-means++ takes into account the distribution of the data points and initializes the centroids in a way that is more representative of the data. This can help the algorithm converge faster and more accurately to the optimal clustering solution. What conditions are necessary for a clustering algorithm to converge effectively? Answer: for a clustering algorithm to converge effectively, the data needs to naturally cluster into well-separated groups. This means that the data points should be easily distinguishable into distinct clusters without any overlap or complex shapes. If the data has overlapping or complex cluster shapes, it can hinder the convergence of the algorithm. What is the importance of choosing the correct number of clusters k in clustering algorithms, and what are the potential consequences of choosing too many or too few clusters? Answer: choosing the correct number of clusters k is crucial in clustering algorithms because it determines the quality of the clustering results. If k is too high, the algorithm may converge slowly or even get stuck in local optima, leading to suboptimal solutions. On the other hand, if k is too low, the algorithm may not capture the underlying structure of the data, resulting in poor clustering performance. Therefore, selecting the optimal number of clusters is essential to ensure accurate and efficient clustering results. What are the purposes of setting a maximum number of iterations and a small tolerance for centroid change in the k-means clustering algorithm? Answer: setting a maximum number of iterations and a small tolerance for centroid change helps prevent infinite loops and determines when the algorithm should stop. This means that the algorithm will stop running once it has reached the maximum number of iterations or the centroids have changed by a small amount, preventing the algorithm from running indefinitely and ensuring that the algorithm converges to a stable solution. This helps to prevent overprocessing and ensures that the algorithm produces a reasonable and accurate result. What is the purpose of tree pruning in XGBoost, and how does it impact the model's performance? Answer: tree pruning in XGBoost is a strategy to reduce model complexity and prevent overfitting. It starts by growing a full tree and then prunes back branches that contribute minimal gains in terms of loss reduction. This process is guided by the gamma parameter, which sets a minimum loss reduction required to make further partitions on a leaf node. By pruning trees, XGBoost reduces the risk of overfitting, which can lead to improved model performance and better generalization to new data. This technique helps the model to focus on the most important features and relationships, resulting in a more robust and accurate prediction. What is the purpose of pruning in machine learning, and how does it help in reducing overfitting? Answer: pruning is a technique used to reduce overfitting in machine learning models. It works by trimming unnecessary branches or connections in the model, creating a simpler and more generalizable model that is less likely to overfit to the training data. This is because a simpler model is less prone to memorizing the training data and is more likely to generalize well to new unseen data. By reducing the complexity of the model, pruning helps to reduce the likelihood of overfitting, resulting in a more accurate and reliable model.